So I have got my IntelliJ open. Let's start solving this problem. I will take the same method name as given in lead code. Just to save some space or do any calculations, let's see that if n is equal to 1, then simply return 5, right? Because we know the answer that if n is equal to 1, we are going to get the 5 as our answer. And in the constraints also, it's given that n can be from 1 to 20,000. So let's quickly if finish our base case here without doing any further calculation, that if n is equal to 1, just return 5. Now we will solve the formula for, the same way as we have deduced in our previous. So let's see here, right? As we have shown that this formula that we have, just one errata in my previous video that I marked u2 as i1 plus u1, but it should be o1, right? Because u can be only followed by an I or O as given here. So u, it only after I or O, not u. So I just corrected this here in the formula and from the previous video. Okay, so let's proceed with the solution again. That let's start with, say, I will mark A1, say, starting with 1. Okay, because for n is equal to 1, I will mark this as A1, A2, A3 and all. Okay, and this would be marked as A2, E2, I2, O2 and U2, and we'll use the same formula as given here. So I will initialize all this A1, E1, I1, O1 and U1 as 1 because this is our base condition. Let me do it here. So I will do this. Just using some shortcuts, A, E, I, O, and U, right? So this is our base condition. And now we will also let's better to have the mod function here. Okay, but before that, let me also create our other variables which would defaulted as 0. So I would be E2, I2, O2, and U2. Because we are not initializing with anything, so it would be by default 0. So this is how we'll calculate this using this formula that we have deduced in our previous video. And also let me create one final long, because here in the statement it's given that the answer can be too large and we have to return the modulo of this. So we should be very careful in doing all these calculations, that we have to always do a mod. So I will show you here how to do that. So I'll just take mod is equal to math dot power of is given as, it's given as 10 to the power 9 plus 7. So I will take 10 to the power 9 plus 7 because it returns me double. So I will just cast it to long. Okay, so now we are ready. Maybe I will just place it up here. Okay, so that our logic is here now. Now let's start with, mark it as J to not confuse it with I. And so we start with 2, right? Because for n is equal to 1, we have already solved it here. We'll only start with 2 to the n, which is given as an input, and it would be this. Okay. Now let's apply this formula. So for each A2, E2, or the string that we are calculating, for example, if you are doing it for, say, n is equal to 2, so we have to use the A1, E1 and all from the previous subdomain problem. Similarly, for n is equal to 3, we see that we have to use all this, the previous n is equal to 2 subproblem solutions, which is A2, E2 and all. So we use the same formula here. So as we have seen that A2 would be based on this I1 and all this, like the first one, and the formula is given here. So it's A2 is equal to E1 plus I1 plus U1. So we simply copy this here. A2 is equal to E1 plus I1 plus U1, right? But we have to notice one thing here is that we have also, because the results can be very huge, we have to keep on uh, taking the modulo of this result to avoid any overflow, because the numbers can be very huge and can be a very huge number which cannot be fit into this. So that's why we will do the same formula here. Okay, now let me again. Okay, so let's do the same formula for all this. I'll just copy it here and maybe I will just put it as a comment like this. Okay, now let's quickly fill this formula. E2 would be A1 plus I1. Remove this. Now I2 would be E1 plus O1, right? And I will remove this. Now let's go to O2. O2 would be simply I1, because for, okay, yeah, it should be simply I1, nothing else. I think we can remove this mod here because we don't need it, because I1 is something which we have already done the mod before, because we are already doing the mod for the previous value, so we don't need to do it again. And finally it would be for U2 is I1 plus O1, so it would be, remove this E1 from here and O1, right? Let me revise this again. So A2 is already E1 plus I1 plus U1, E1 plus I1 plus U1. E2 is A1 plus I1, E1 plus O1, I1, and I1 plus O1. Yeah, that's it. I'll remove this now. And now once we have calculated these new values for O2 and U2, so I will just mark this A1 as A2. So what we are doing is that once we calculated all these values, now for the next row, for the next n is equal to 3, for the next case, A1 will become A2, right? And this formula would be changed to like this: A3 is equal to should be E2 plus I2 and U2. So we are just replacing all these numbers with the previous subdomain problem or the subdomain number that we have calculated here. This is the same thing that we had. Now A1 becomes A2. Similarly, I will again do this, and this my E, I, O, and U. Similarly, would be E, I, O, and U. So we just replace the swap these values again, and it will keep on calculating till we get n. And finally, the result would be here. So our A1 and E1 would be our final result after we have moved till n. This was all the for loop formula, and now we just need to calculate the result. So I will start with 0L. And again, we simply cannot do A1 plus A2, E2 plus I2 and all, right? Because the sum can be again very huge, and we have to do the mod for each of the result calculations. So here I will do this simple and naive way to just do result plus A1 a mod, okay, and then again same thing, E, I, So it's just a little bit of typing here. So once we have this result, then we return result. Yeah, but we have to return the result in the form of int. So I will just cast it to int. That's it, guys. We just use the same formula as we have deduced here in our previous algorithm. We just did the same thing. Now let's run it and see whether it works well. So I've used both the cases 2 and 5 from the example given here. So 2 and 5. Let's run for this. So it's 10 and 68. It matches our solution here. So let me copy and paste this problem here in LeetCode and see whether it works for all the cases. So I'll just copy the same thing from here and submit it. So as you've seen, that it's quite an efficient algorithm. So let's quickly calculate the time and space complexity. So for the time complexity, let me see. There's only like one for loop, right? So for one for loop, it's only from 2 to n. So it would be O of n. And here we are not creating any type of DP array or 2D array. We are just using the simple. So it's the space complexity is quite efficient here. That's why we have got a very better performance in LeetCode. So it would be O1 because we are not maintaining any extra space except this long characters, which is constant. So guys, this was all about this hard problem as mentioned for count vowels permutation. In the next video, we will solve the 22nd problem of our tutorial series on dynamic programming, which is target sum. And again, we'll solve this problem in LeetCode. So see you all in the next video.